Let me point out something here that I didn't mention in the previous diagram here we looked at just now. So these shadings shown here are the so-called OLR, outgoing long wave radiation, at the top of the atmosphere, which is basically the Stefan Boltzmann law for how the planet is losing energy to space. So it's receiving shortwave energy from the sun, everything is getting heated, evaporation, clouds forming, and then there is some emission temperature which determines the outgoing energy, which is written as epsilon m sigma sb t to the 4, where T is the emission temperature, epsilon is the emissivity or absorptivity. If it's 1, it's a pure black body, and sigma is the Stefan Boltzmann constant. Where you have low OLR, outgoing long wave radiation, temperature is low and it corresponds to deep convective clouds and cold cloud top temperatures, so generally can be used to infer rain. Not always, because the scale of the OLR tends to be much larger in terms of the minimum, whereas the rain within that is much smaller scale. Nonetheless, this figure is comparing a weak La Nina to a strong El Nino to look at the contrasts in the zonal circulation or the Walker cell shifts, and the El Nino peaks in the boreal winter, December, January, February months. We will see later on that this is why it's was called El Nino, the Christ child, because anomalously warm waters showed up off of the usually cold coast of South America during winter time. So the Spaniards, good Catholics that they are, thought this was a gift from God. I have podcasts on El Nino as well that you can look at. Coming back to this course, in terms of tropical dynamics, you can see that there is strong region of low OLR, minimum in OLR, which is corresponding to high rainfall or deep cold temperature top clouds, cold temperature top clouds, and there is strong rising motion hitting the ceiling, divergence, sinking over eastern Pacific, where there is cold upwelling waters, high pressure. So low pressure, high pressure, and there is Amazonian convection, of course, and there is sinking over parts of western India, deep tropical western Indian Ocean, and East Asia. And during an El Nino, essentially that convection sloshes to the east along with the warm waters in the ocean. We will understand the dynamics later on. You can see the extension of the 28-degree isotherm here, much broader, much further east, and the minimum OLR is spread out as well, and the rising motion has shifted towards the east, and there are rising motions here instead of the sinking motion, so you get anomalously high rainfall here, anomalous dryness over Indonesia, Australia, and anomalous rainfall over here, and so on. So we'll learn about global teleconnections of the El Nino, but right now this is just meant to show you how the entire zonal circulation, this is called the Pacific Walker cell, this is the Indian side of it, there is an Atlantic side, and typically when we say Walker cell we are talking about the Pacific Walker cell. Okay, so that's briefly a jump to El Nino, and then we'll go back. Add monsoon to it. So looking again at the boreal summer and winter months, we already mentioned the southwesterly winds, which are coming from the strong southeasterly trade winds here, which remain throughout the year. So Indian Ocean has a trade wind regime south of the equator, but to the north of about 5 or 10 south, winds completely reverse. So you can see here in the summer months there are strong southeasterlies here cross the equator and create very strong upwelling here. You can use your Coriolis here. If winds are trying to drag the water to the north, Coriolis will push it to the right, so water will move away from the coast, which means cold water from below will come up, which is what we call upwelling. So you can see that the rainfall disappears because you need warm temperatures for rainfall. So you have strong convection and rainfall over the warm Bay of Bengal, and the marine ITCZ remains. And of course, the Himalayan foothills and the Western Ghats get a lot of rain. Core monsoon region gets rain. And note that maximum rain tends to be on the Bay of Bengal, which is also related to this mountain ranges over Burma, Malaysia, and who else? Thailand is here. And there is the West African convection and the East African monsoon with the short monsoon season before the Indian monsoon, or the long monsoon season before the Indian monsoon, and the short monsoon season after the Indian monsoon. Okay, so this is the all India rainfall shown here, and the ITCZ stays to the south when the sun moves to the south in the northern hemisphere winter month. And you can see the changes over here as well. As we saw, the whole warm pool sloshes a little to the south, so you can see the impacts, and you can see the similarity of the Australian monsoon here during the boreal winter months, similar to the African kind of situation happening here. So rainfall over these regions pretty much throughout the year, but there is a drier season relatively during June, July, August compared to the winter months. There are of course monsoons in other regions as well. Monsoon is a word that presumably came from Arabic, which means mausim or season. The Arabs had learned to use the seasons to go back and forth. So if you want to sail from here to here, these winds are favorable. If you want to go back, these winds are favorable. But there are some arguments that it could have come from Danish and other languages which have somewhat similar words. It's possible that Arabic was was the origin anyways. Okay, so there is the South American, Central American monsoon season. You can see the sun is to the north, ITCZ is to the north, so you can see broad band of rain over here. ITCZ is clearly seen, and when the sun goes south, ITCZ shrinks and shifts to the south and the rainfall disappears. You can see big changes here. And the southern part of the Amazonia gets a lot of rain during this season as well. And there is the African monsoon with the ITCZ going back and forth, and you can see the change in circulation here as well. You can see some change in circulation here and some change here, but nothing as dramatic as this one, right? So you can see that these are massive seasonal shifts. So this is, in general, when we say monsoon, this is what we talk about, but this is called North American monsoon, and this is called the West African monsoon, and so on. Let's leave it there and come to the ocean in the next podcast, but I hope you're getting a sense of the global roadmap for winds, temperatures, humidities, moisture fluxes, rainfall distribution, and tropical circulations in terms of winds and monsoon, rainfall, moisture fluxes.